This hokey looking cooler sitting in there with foam and zip ties is for my transmission. And alright guys, let's run these wires. Now what we'll do with these wires is we'll pull them right up off the back of the fan and zip them right here real tight, so there's no way they could make it over to that pulley or anything. Okay, we'll do all the wiring and hanging of the relays and whatnot right here, or we could do it over here, wherever we wanted. We could do it over by the battery just to make the wire shorter, but it's pretty busy over there with the isolator and everything else anyway, so whatever, we can do whatever we want. I'll figure that out. But the main thing is you can't have that getting in the belt. That'll make a mess real quick. Okay guys, we got the fan mounted, the next step, and we got the switch installed. We've got a positive fuse holder with thick enough wire rated for 30 amps to be a full-time positive feed for, I already loosened that up and worked on that and made sure that was going to go on. So we're good there to have a fuse for our system. Then on the other side of this wire, we can power both the coil and the fan itself. A lot of relays, and I'm not going to make this a video about relays because I could spend 3 hours on relays. I know how to give you 3 hours of information on what a relay is and how it works and what it does. Some relays have 5 poles, some only have 4. Some of them are jumped where you're actually only using 1 feed to do 2 positives, which is the setup I'm going to do here. So without getting into a wiring lesson and why it works that way, I'm going to keep it real simple, okay? The 2 small wires, the 2 thin ones, are the coil side of the relay. That's what does the switching for the fan, okay? The yellow is the hot side of that. So the yellow is always positive, okay? 100% always. We're not going to have a keyed ignition on this. The reason we're doing that is because if you park your vehicle and it's really hot outside and you turn it off to cool it down, we want to let the fan run for a second, even if it does pull a little bit off the battery. So once the engine cools off and the ground switch and the pump lets go, it'll stop pulling juice. So in theory, you're not going to kill your battery with the fan, you know, if everything's working properly. So this is all. You could go to a switch source for that, and then it would automatically turn the fan off with the key if you wanted that. I don't care. I'm going to go straight to the battery. So that's always hot, right? Like that. You got 12 volts always going to the switch side of that. Now the ground side of the switch goes down to the switch in the water pump, okay? That circuit gets completed when that switch closes. That switch closes when it gets hot enough and it reaches the right temperature, okay? So we're going to run this wire back along down here like that to the switch. Okay, that's where that's going to go. So I'm just laying all this out so I can figure out how long my wires need to be. If this shorts, it could start a fire because that would be a short to ground, from positive to ground. Okay, if this rubbed on that and rubbed through and got jacked up, that could cause a fire. So this has to be fused. So this fuse will go between that positive and the rest of the system, so that if it did short out, it would pop the fuse. Yes, the fan wouldn't work because the same fuse is going to also do the fan blades, fan motor, but you know, I'd rather have the fan fail and then me notice the fan fail because I'm getting hot when I'm watching my engine gauge, like you should. I'd rather have that than catch the vehicle on fire and melt it to the ground. So I'm going to fuse that. This does not need to be fused. Why does this not need to be fused? Because it's already a ground style device. The only thing that would happen if this rubbed through something and ground is it would turn the fan on. So if you turn the key off and your engine's not cold, or if you're getting out of the vehicle and the fan's running and you know it's not hot enough for the fan to be running, then you know the ground wire is shorted on the coil side of your relay. Okay. The two fat wires, the thicker ones, okay, the red one will go straight to hot just with the yellow. Remember I said I'm going to use one hot to feed both sides of this. Okay, it'll be fused. It'll be fused. So we'll cut those wires there, solder them all together like that, and then fuse it. But this will also always have power. Again, so if the engine's really hot and you're trying to cool it off on a nasty hot day and you turn the key off parking, it'll go ahead and run the fan for a little bit. Okay. The other side, this purple wire, is the ground side, not the ground side, but the switched side of the hot is what I'm going to use it for. So when the relay switches on, okay, so let's go over the process. When the switch contacts, because it's hot enough, it'll complete the circuit across the yellow and the black. There's a magnet in the relay. That magnet will contact the red and the purple. The red's going to have hot on it, so this becomes hot to go to the fan. That goes to the fan wire. Okay. Then the other side of this goes to ground. Okay. We'll make a nice good ground somewhere on the chassis or the motor or somewhere. Or if I got extra wire laying around, I might even run a piece of black wire up to the ground, right there. Would be ideal, but maybe I'll just clean up one of these bolts real nice and make a connector and get a nice shiny surface with no paint or rust and ground it out, like there or something. There's a number of options I could do. We'll see what I feel like doing. But that's the wiring schematic. Black to the switch, yellow to hot, red to hot, both of them combined on a fuse. Purple to yellow, black to ground if this is a pusher fan. But since I'm pulling, I'm going to go purple to black, yellow to ground, and just run the polarity of the motor backwards because I want it to pull instead of push. That's what the instructions say in the fan box. You can make that fan spin either way, and it's designed to go on the radiator in the front and push through in the back, but I want it to pull back and pull out, so I'm going to reverse polarity on those blades. Alright guys, I'm going to get these clippers out, and I'm going to start clipping wires in in an area where I think my lengths are going to be somewhat right. It's always easier to leave a little extra, guys. Leave a little extra and wrap it up is a lot easier than cutting stuff too short. Okay, now I've got my wires all cut where I want them to be cut. This will get soldered. This will get spade connected so it can be put on and off the switch. These will get soldered to the ring terminal fuse carrier. Alright guys, I'm going to do that part. Okay guys, we got our wiring for our fan controller on here. We took hot right off the battery. I got to get a 30 amp fuse to put in there. I got one in the Toyota. I'll go grab that in a second. We'll put a 30 amp fuse in there. that feeds hot to the coil and the fan, because I soldered them together right there. The yellow hot crosses to the control side looking for ground. So if it finds ground through that switch, it'll turn the magnet in that relay and suck it down and make contact. Once that happens, once that switch is hot enough to ground, then the purple and red wires will get connected inside the relay. And what will happen then is the 12 volts that's coming out of the red right off the battery will jump over to the purple. Now notice I've got the colors backwards on this fan. I think I mentioned that already. I reversed the polarity because I'm pulling instead of pushing with this fan. So the hot that comes out of that relay, that purple's hot right there. It goes into the fan and then back out the fan, and this is the ground for the fan. Okay, I'm gonna get a black wire and replace this purple one with black because I don't like using any color for ground other than black. But the black wire that I had left in the kit is too thin a gauge. It's too thin a gauge to run the power of the fan on. It's only thick enough for the control side. And you see they use black wire on the control side, but it's a thinner gauge. So to have enough, you know, to carry enough amperage, I use this thicker purple wire. If any of this stuff touches, grinds out, you know, makes contact or anything, this fuse will pop. Okay, that fuse will blow. So the only thing left to test this is we can touch this right to ground. You know, here's a good ground here. We can touch it to that and see if it turns the fan on, even without the engine being hot, because that switch is just a switch. We could touch that spade to ground and it'll accomplish the exact same thing. So let me turn the camera off and go get a 30 amp fuse out of the Toyota, and we'll test this fan before I run this last wire. Okay, we got a 30 amp fuse feeding both the coil and the fan itself combined. We're getting ready to jump the coil side, the magnet side of this relay, make contact, and we'll see if the fan turns on. Let's find a decent ground. See if you can hear the fan come on. You might hear it in the camera, I don't know. There you go. Hear it, guys? I don't know if you can hear it. I don't know if you can see it either. I'm going to put the camera back there. I know it's dark. I have no idea if you can see this or not. But I don't know if you can hear the relay clicking. I got the camera right next to the relay. So so we know the fan works. We know we're good there. We know it turns over, we know it pushes air, we're good to go there. The only thing we need to do now is test the switch. Okay, I could have done that earlier while the engine was hot by getting it hot enough to make ground and then taking a voltmeter to see if it made continuity to ground, but I didn't do all that, and it's getting dark and I'm running out of daylight. So here's how we're going to test it. We're just going to hook it up and we're going to run the motor, and we're going to put a heat gun on this radiator to make sure that we don't overheat this engine. Okay, I know from experience, from 30 years of doing this, cars, bikes, everything else, the radiators get to about 215, 210-ish when the engine's at about 220. There is a little bit of lag. There's a little bit of delta there. So I'm going to watch the radiator with a temp gun, and with no fan back there, and if I was careful not to hit the belt, I could actually get the get the temp gun right on the water pump and see how hot the water pump gets. When that water pump breaks a couple hundred degrees, the engine's safe all the way up to about 220, 225. I would venture to say, I don't recommend this, but I would venture to say you could probably get a Chevy small block all the way to 230 without really hurting it. I know with the race car engines and stuff, they get them that hot all the time. So, not on purpose, but just because of racing. So I'm going to get my thermometer out. We're going to see how hot this gets, and hopefully the fan turns on before it gets to, say, 210, 215. I would accept it. I would be okay with that. 205 to 210 would be ideal. But then I want to see when it turns off. Then I want to see, does it turn off before the thermostat closes back again? Because if it stays open the whole time, you know, let's say you get it hot sitting at a red light or sitting in traffic, the fan's helping cool off, and then you start driving again. Well, it might stay 190 degrees the whole time you're driving. If the fan doesn't turn off till 180, then the fan's running the whole time you're driving for no reason. So I want to test that as well. I want to make sure it comes on when it's supposed to, and I want to make sure it goes off when it's supposed to. All right, guys, I'm going to stop talking and fire this thing up and get it hot, and then go get the thermometer gun, and we'll see how hot it gets. Okay, I started it up a few minutes ago, went inside and did a little tinkle, and it's been running a few minutes. I got the sender wire, switch wire hooked up back there. You know, you can see I got it running down behind the back of there. Now, if that shorts out, it could kill the battery because it'll turn the fan on. If that shorts out the ground, the fan will just run, because once that contact finds ground, it's going to magnetize that switch and throw power at that fan. So, you know, if that were to short to ground and bypass the switch, it'll run the fan. But I'm not overly concerned about it, because if I turn the van off and get out of the van and walk away and I hear that fan running, I'm gonna know. I know my van and I pay attention pretty well, and if it kills the battery, then it's bad on me. But yeah, it works. Once that switch gets hot, well, the fan side works. Once that wire gets ground, we know that fan comes on. So let's see how hot this motor gets before the switch works. We're at 115 degrees on the radiator and 62 on the upper hose. What does that tell you? Heater hose 130, 128. Oh, I see bubbles moving over here. Sorry, we're running out of daylight, guys. I didn't get started on this project till about 1 o'clock today, and it's about 4:30, 5 o'clock, starting to get dark. This project, without the camera edit work and on and off, and, you know, trying to be with you guys, thanks for coming along. Without that, this would probably be about 3 hours worth of work. Probably took me another half hour, 40 minutes to stage things for the camera, you know. But look at all that stuff we're not putting back in. We're not putting the cold air intakes back in. We're not putting the shrouds back in. We replaced the hoses. We replaced the radiator. I don't see any leaks where we pulled those fins through and they got a little kibotulated where we pushed that holder through there. I don't see any leaks. We don't have a lot of pressure on the hose yet, but it's still pretty cool. So the water pump is at 150 degrees long before the thermostat opens. So that gauge should be pretty low. Yeah, it is. It's pretty low. I'll turn the lights on. Maybe that'll help you see it. I don't know if it helps or not in this daylight, but the gauge is way low. It's nowhere near warm yet. So I'm going to turn the camera off because this is the boring part, the waiting. It's going to take probably 7, 8, 10 minutes. So I'll see you in 7 minutes. Catch this on film, but I think I missed it. It was bubbling a second ago and pushing air up because it got a little bit more air in the radiator and made it up there, and the radiator's getting warm enough to where it's starting to exchange. So I saw some air bubbles moving. But heater core hose 160, radiator still only 130, upper hose cold, guys. Look, it's only 70 degrees, so thermostats, I haven't even thought about opening up yet. But we're getting a little temperature on that heater core hose, so that means the motor, or the engine, motor's going RC cars, right? The engine should be heating up. Yeah, see, there it is. That's about where it sits normally at idle with the old fan setup on it. The old fan setup was constantly cooling even when you didn't want it to be. So on a cold day, it would keep the thermostat just teetering on overworking the thermostat because that fan's always pulling. The way the system is now, the thermostat will open and it'll stay healthy open and be good and warm, 190, 195, 200, whatever it is, and it'll stay there sitting at idle and keep your heat working, keep your defrost working. On really super cold days, I'm talking 5-10 degrees ambient outside, I had problems where this thing wanted to run so cold that the heat wasn't working real well, because with that fan pulling across that radiator in that super cold weather, the thermostat just couldn't hardly ever even stay open at idle, you know. Now, if you were driving around town at 15 or 20 degrees, it would warm it up because you were loading it a little bit and not going fast enough to get a lot of air across the radiator. Remember, I said you need about 30 miles per hour for that. So, all right, we are at the normal operating temperature that this thing used to always run at. I'm hoping it runs 5 or 10 degrees warmer now without the constant fan pulling on it. It'll be more efficient if it did run a little warmer. Oh, there's air bubbles. I don't know if you caught it in the camera. I just saw another bubble move. That's not good to have that clear hose on there. I won't keep that on there. That hose will degrade very quickly because it's not made for that kind of chemical and that kind of heat. I'm going to replace that as soon as I get one to fit it. But, you know, it's neat for you to see the bubbles move. Alright, so we're getting decently warm in the engine. The block and the pump are, I'm getting all kind of different readings, probably because I'm hitting moving parts. Yeah, the block says 190 degrees now. So when the block's 190, the heater core is 173, the upper radiator hose still isn't even open yet. It's warming up through osmosis and through temperature, but you know, you see it climbing, but it's not over 185 degrees where it opened, you know, or 170 where it opened. So thermostat still has not opened yet. We're barely over that line. Barely over that line. Yeah, the bottom of the engine block right at the head near the exhaust manifold is at 200 degrees. The hottest part of any engine is the cylinder head right next to the exhaust and the cylinder right next to the exhaust area, because all the escaped gases go out the exhaust port. The intake sides are cooler because the fuel charge and the air charge coming in is cooler. So the intakes are cold from air coming in, and the exhaust gets hot because it's literally getting all the burning exhaust to go out. So the exhaust side of that head is over 200 degrees. Let's see if we can get a shot of the manifold somewhere. Nah, I can't really get to it. Not safely. The pump's around 185. Yep, there you go. 178, 109, 879. Yeah, this upper hose is climbing in temperature big time, so the thermostat is now open. It is now open. My fan just kicked on. Let's see where the fan kicked on at. On the gauge. Yep, see where it's nowhere near dangerous yet, but warmer than normal when it had the standard Chevy fan. So the radiator's at 160 still. Yeah, I'm super happy, guys. I'm super happy. Yeah. Let's see if it runs and actually cools off. Yeah, it cooled that upper hose. Yeah. See, we went from 180 down to 170 and it cut off. It's perfect, guys. It's perfect. It's coming on when the engine itself gets up around, you know, 200. And then it shut off when the engine went back down around 190. It's absolutely perfect. Now, when will the engine run a little cooler than that? The engine will run cooler than it is now when I'm going down the highway. Why? Because the fan won't be on. It'll be getting maximum airflow across the radiator, and while I'm going down the road, it'll get all the air it needs to cool as much as it needs to. And the thermostat, if it's cold enough, will start to close. The thermostat will actually start to close. When it gets hotter, that's only going to be because you come to a stop, right? Or you're driving slow. When you're driving slow and come to a stop and it gets hotter, then it's going to get hotter than it ever did before, because it never got over 185 before. Well, it's going to go to 200 now, and I'm okay with that, because it's more efficient to drive around town at 200 degrees than it is 185. It's better for fuel economy. It's better for your spark plugs. And there's no danger to the engine till you get up around 225, 230, 240. So let's see when it turns on again. We're starting to get up over 200. We're 205, give or take. Yep, and that's what that switch is rated for. It says it turns on at 205, and it does. We were at 204.7 or 8 or whatever it said on here. You can look in the video, but 204 something it turned on, and now it is on. I can feel plenty of flow. It's working real good. We're getting plenty of air exchange. Yeah. Yeah, it's working, guys. It's working good. All right, it just turned off again. Let's see where it turned off at. It turned off at 185, which is what it's rated to do. 179, 182. I'm getting weird numbers because I'm moving. But that radiator's in the 170s. Man, I couldn't be any happier. It's coming on when it should. It's going off when it should. It's working. All right, guys, that's how you put new radiators in your vans. That's how you put, you know, fan controllers on. That's how you mount the fans on the radiators. So I got to get a hose for this, and I got to get solder so that I can take that crimp joint out, because that's just crimped and I don't trust it. I want to cut that crimp out and solder it good and put an eyelet on the end of that ground, because it's just jammed in there. I didn't have solder or an eyelet for that. So all is good, guys. Thanks so much. Be safe, wear your helmets, take care of your trucks, guys. They'll take care of you.